Welcome to part 2 of our episode on oceans and climate change. I'm Laur Hesse from the MIT Environmental Solutions Initiative. If you haven't checked out our part 1 on oceans, I highly, highly recommend that you do. It gives an important context for this episode, including the role that the ocean plays in helping regulate the elements that keep life alive. So our featured guest today for this part 2 is, again, Dr. Sylvia Earle.
Explorer at large at the National Geographic, founder of Mission Blue, basically an oceanographer.
Dr. Earle has spent decades studying and diving in the ocean.
When astronauts go up in the sky, they have spent enormous amounts of time trying to understand their life support system and do everything they can to take care of their life support system. Why? Because their life depends on it. You have to know what you're breathing. You have to be conscious of the temperature. And here we are as residents of Spaceship Earth. We need to care for our life support system. And we still have a lot to understand, but we do know that we're doing things that are altering the basic chemistry and temperature of the planet. And it is putting us at risk.
In part 1, we covered how humans are changing the chemistry of the ocean. Today, we're focusing on the other thing that Dr. Earle mentioned, temperature.
Change the temperature, and you change everything.
So we know that global temperatures are rising. Is this happening in the ocean too? And what effect is that having? First, we got to tease out how temperature in the ocean works differently than temperature change on land. So, imagine you're about to step out on the beach on a hot summer day. I'm thinking about a beach in New Jersey where I went a lot when I was a kid. You're looking at that big section of sand that you want to cross in order to get to the water. So you take a step and, ouch, it's really hot. So you run up to the water and you dip your feet in, and it's still pretty cold. But why? The sand and the water are both sitting out under the same sun. Well, the sand absorbs and releases heat more quickly, which is why it feels hot on your feet. Water, however, can absorb a lot of heat before it radiates it back out. This means the ocean doesn't experience rapid swings in temperature like we can on land. Where I live in the springtime, one day it might be 70 degrees, but the next day it's down to 50. That doesn't happen often in the ocean. Because of water's incredible capacity to hold heat, the ocean can, and is, taking in a lot of the extra heat that we've created by adding CO2 to the atmosphere.
Because of the ability of the ocean to absorb the temperature, it holds the heat over a longer period of time than at the surface or on the land. It's a gradual process, but the ocean is becoming warmer overall.
Warming affects the ocean in a lot of ways. First, when the water gets warmer, it actually loses some of its ability to hold carbon. The higher temperatures make it less likely that CO2 will go through the chemical reactions that turn it into the forms of carbon that tend to stay in the ocean longer. So more of it will stay on the surface, and so more of it will go back out into the atmosphere. This is something called a feedback loop. Levels of CO2 in the atmosphere rise, the planet gets warmer, the ocean gets warmer, it can hold less CO2, which releases more back into the atmosphere, which makes the whole planet warmer, and global warming actually accelerates. And as you may remember from our episodes on sea level rise, water expands when it gets warmer, and sea ice melts. So that contributes to rising sea levels. Warmer water can affect ocean life too, like coral reefs.
Corals are sensitive to temperature. They live within a fairly narrow range. And yes, they do like it warm, but not too warm. And they don't like it too cold either. And when the temperature stays warmer than is comfortable for them, the algae that live in their tissues that are critical to generating food and perhaps also oxygen for the corals. They either die or they escape. In any case, the phenomenon known as coral bleaching occurs. It just looks like a snowstorm on a coral reef when this happens.
Why do we care about this? Well, coral reefs provide one of the most important ecosystems in the ocean. They support more species per square foot than any other marine environment, and support billion-dollar industries like fishing and tourism. Many medicines, in fact, are developed from life around coral reefs. And the U.S. National Oceanic and Atmospheric Administration, NOAA, says that coral reefs buffer shorelines against 97% of the energy from waves and storms and floods. They do an incredible job at helping to protect the property of the millions and millions of people who live near coral reefs. So you might be wondering, what does this all add up to? What's going to happen to the ocean if we keep putting carbon into the atmosphere and the planet keeps getting warmer? Well, scientists are getting a picture, but they aren't exactly sure how this will all play out. There isn't a scientific consensus yet on how much carbon or heat the ocean can absorb, or how acidic it can get, or other impacts like how the currents might change, which is actually something that scientists are pretty worried about.
We know more now than ever before, owing to discoveries made literally since the middle of the 20th century. A network of monitoring stations has come into form, the Global Ocean Observing System. And Argo floats. These are systems that follow the ocean currents, deployed from the surface, descend and travel with the currents, and then pop up periodically and send their data back to satellites that go back to land-based receivers.
What do those look like? Are they like little robots?
Little robots, cute little robots, yes. The Argo floats descend from the surface and look at the water column and travel with the currents and then come back up to the surface to put their data back into those listening from above. There are thousands of these around the world. Did not exist when I was a kid.
These little robots are helping us monitor temperatures, acidification levels, and more, and how these things are changing over time.
21st century humans, we are probably the luckiest people ever to arrive on Earth, because we know we've got problems. We can see them. In some cases, we can taste them. We can certainly measure these changes. And therefore, unlike other intelligent creatures like whales and elephants and cats and dogs and even some very smart fish that I know, we can do something about this.
In these 2 episodes, we skimmed the surface of the relationship between the ocean and climate change. If you want to dive deeper, we have an ocean of resources in our show notes at tilclimate.mit.edu. Just swim over to the episode page. If you're an educator or know educators in your life, we've developed a flexible set of activities to bring climate topics like this one into your classroom. We write them so they can fit in with existing STEM or non-STEM curricula, and incorporating the TIL podcast introduces a fun way for students to engage and learn. Check out climate.mit.edu/educators. You can also download our guides for free on the educator sites Teachers Pay Teachers and Subject to Climate. And as always, we'd love to hear from you. Find us on Twitter at TILClimate. We have an exciting season coming up for you, so please subscribe and review this episode. We'd love to hear what you think. An enormous thanks to Dr. Sylvia Earle for joining us as our guest expert for this episode, and also to Dr. Carolyn Bastidas and Dr. Jonathan Lauderdale for their extra help in explaining the incredible complexities of the ocean to us. And thank you for listening. Today I Learned Climate is produced by the MIT Environmental Solutions Initiative. Our editor and producer is Dave Lishansky. Our associate producer is Aaron Krol. Natalie Jones is our scriptwriter for these 2 episodes. Ilana Hirschfeld is our production assistant. Sylvia Scharf is our climate education specialist. Carolyn Shea was our fact checker. Our music was by Blue Dot Sessions. Our artwork is by Aaron Krol. And I'm your host and producer, Laur Hesse Fisher.